Now, you are going to learn about the term called frequency. Here, in simple harmonic motion, certain terms must be thoroughly known. One of the important terms is frequency. What is frequency? Look at that. I have kept three tuning forks. The frequency of the first tuning fork is 280 Hz. Frequency of the second tuning fork is 380 Hz. Frequency of the third tuning fork is 480 Hz. Here, what that number indicates that you should know. When the tuning fork, when it is hammered, the prong, that one will vibrate in simple harmonic motion. The prong, that one will vibrate. That vibration that is shown here. Here, what that number shows, 280 hertz means per second. Within a second, how many number of vibrations will be cast? 280 complete vibrations will be cast clear in the tuning fork, prong of the tuning fork. Within 1 second, how many number of vibration will be taking place? 280 vibrations will be taking place in 1 second. Such number is called as what is this? Frequency. So how will you define frequency? Number of vibrations made by the particle in 1 second is called as frequency. Are you clear? Even you may have learned this definition of frequency in the lower classes. Here, with the help of tuning fork, I am explaining. So within a second, how many number of vibrations are seen in this tuning fork? 280 complete vibrations will be taking place in 1 second. Such number is called 280 hertz. Vibrations per second is called as hertz. The unit of frequency is hertz. Look at the second one. In the second tuning fork, it is mentioned that the frequency is 380 hertz. When the tuning fork, when it is hammered with the help of hammer, the prong of the tuning fork, that one will vibrate like this. The vibrations are very microscopic and we are not able to see. Are you clear? So when the prong vibrates, how many number of vibrations will be created in 1 second? 380 vibrations are created in 1 second. That vibrations per second is mentioned as hertz. That's why it is mentioned that 380 hertz. The frequency of the first one is lesser. The frequency of the second one is more. Let's see the next one. The last one, tuning fork, its frequency is 480 hertz. What that 480 hertz indicates, when the prong, when it is made to vibrate, that one will vibrate here and there in to and fro motion. When it vibrates per second, how many number of vibrations are created? 480 vibrations are created per second. That's why it is mentioned that 480 hertz. Now you have learnt about what is frequency. Now we are going to learn what is time period. What is time period? Here, so many number of vibrations are taking place. 280 vibrations are taking place per second. Are you clear? Now we have to find out what is the time taken for one vibration. Are you clear? Look at that. What is one vibration? So it has to start its journey from here. It has to go to the right extreme end. Again, it has to cross the mean position. Again, it has to go to the left extreme. Again, it has come back to the mean position. So this is called one vibration. To complete one vibration, it will take some time. No, that is called as time period. So how to calculate the time period? That is time taken for one vibration. By knowing the value of f, we are able to calculate the time period. So first you should know the relationship between frequency and time period. So time period t is equal to 1 by f is the formula. Reciprocal of the frequency is time period. Substitute here, t is equal to, time period is equal to 1 divided by 280 hertz must be substituted. Here I will calculate 1 1 divided by 280 is equal to, what is the answer shown here? The answer is 0.0035 seconds. Are you clear? To complete one vibration, how much time it takes? That prong takes. That prong it takes 0.0035 seconds it takes. Let's calculate the time period in the case of 380 Hz tuning fork. Again, we have tried the same formula. T is equal to 1 by F, which is equal to 1 divided by 380 to be substituted. Again, I am going to calculate it for 380 Hertz tuning fork. 1 divided by 380, which is equivalent to, what is the answer? 0.0026 seconds. Are you clear? So here, in this case, the time taken to complete one vibration is how much? 0.0026 seconds. You just compare both. In the previous case, frequency is less. Frequency is less, but time period is more. But in the second case, frequency is more, here time period is less. It shows that the time period and frequency both are inversely proportional to one another. Let's calculate the last one. Here in this case, what is the formula again? T is equal to 1 by F is the formula. Substitute here. 1 divided by 480 Hertz must be substituted. So here 1 divided by 480 substitute. So what's the answer? 0.00208 seconds. Are you clear? So look at the time taken here. In this case, the prong it takes 0.0020 seconds to complete one vibration, complete vibration. So we have calculated the time taken in all tuning forks, time period in all tuning forks. In the meantime, we have learnt what is frequency. Are you clear? Next, we are going to learn what is angular frequency. What is angular frequency? Here, this f is nothing but linear frequency. In some cases, we can call it as linear frequency. Next, we are going to learn what is angular frequency. That angular frequency is mentioned by the letter omega. Are you clear? By knowing the value of f, we can calculate angular frequency. Okay. Now I am going to teach you what is angular frequency. Already we have learned that in the case of simple harmonic motion, that simple harmonic motion, it is nothing but that is a projection of the circular motion. Are you clear? So when any particle, when it is moving in the circular path, when the projection is extended towards either towards x-axis or towards the y-axis, that projection point, that one will be moving in simple harmonic motion. So by knowing the value of f, linear frequency, we are able to calculate the angular frequency. So what is the relationship? Omega, this is called as angular frequency. Omega is equal to 2 pi f. So this is the formula. So by knowing the value of linear frequency, we are able to calculate the angular frequency. Look at the uh, diagram here. Look at the animation here. Here in this animation, that particle that is moving in the circular path. Are you clear? But what happens? Its projection, that is moving here and there in the simple harmonic motion. Are you clear? So the simple harmonic motion particle that is having linear frequency. The particle which is moving in the circular path is having angular frequency. Are you clear? By knowing the value of linear frequency, we are able to calculate the angular frequency. Are you clear? So let us take this typical example. Here f is known. F value is 280 Hertz. By knowing the value of f, we are able to calculate angular frequency. So what to do? Omega is equal to 2 pi into 280. Substitute all the values here. Now I am going to calculate the angular frequency in this case. Are you clear? So 2 into 3.14 into 280 is equal to, how, what is the answer now? 1758.4 radian per second. Radian per second. So this is the uh, factor called, what is this? Angular frequency. That must be written like this. Understood? So or we can write it in some other form also. Instead of converting pi into 3.14, so clear, we can calculate like this: 2 into 280, which is equal to 560. 560 pi, 560 pi radian per second. So this is also another method of giving the answer. Are you clear? So by knowing the value of f, we are able to calculate the angular frequency. Are you clear? So in all cases, in simple harmonic motion concept, by knowing the value of f, we are able to calculate the angular frequency. Look at the animation shown here. In this animation, clear, the particle that is moving in the simple harmonic motion. Are you clear? It is moving here and there. But that particle which is moving in the circular path, that is moving, go around the circular path, no, there from the projection is taken. That projection alone it moves in the simple harmonic motion. The simple harmonic motion particle, that one is moving here and there, that is one is having frequency. The particle which is moving in the circular path is having angular frequency. Understood?